Levy, and I'm the director of the Center for Advanced Study in Behavioral Sciences, infelicitously known as CASBS. See if you can say that. I'm really pleased to welcome you to the first of our symposium series this year. And what we're doing this year with our symposium series is inviting current fellows or consulting or visiting scholars to present material that we think would be interesting to a wider public, including Stanford people down the hill and others in the larger Bay Area community. So let me introduce the speaker. Fox Harrell, PhD, is an associate professor of digital media in Comparative Media Studies program and the Computer Science and Artificial Intelligence Laboratory at MIT. You see why I had to read that? That's a lot of stuff. His research explores the relationship between imaginative cognition and computation. At MIT, he founded and directs the Imagination, Computation, and Expression Laboratory, which you probably could get the acronym much better than CASBS, the ICE Laboratory, ICE Lab, which develops new forms of social media, gaming, computational narrative, and related computational media systems based in computer science, cognitive science, and digital media arts. The National Science Foundation has recognized Harrell with an NSF Career Award for his project Computing for Advanced Identity Representation. He has worked as an interactive television producer and as a game designer. His book, Phantasmal Media, An Approach to Imagination, Computation, and Expression, was recently published by the MIT Press. And he does have other identities. I won't tell you all of them, but I should mention that he has one of the most gorgeous sons I've ever met, thanks to both Fox and his lovely wife.
Okay. Well, first I'd like to thank Margaret for the gracious introduction and everybody here at CASBS for attending and for making this possible. So I'll be speaking tonight about computation, imagination, and identity in phantasmal media, and a bit about my research. So my research explores and focuses on developing AI and CogSci-based technologies, as was mentioned, interactive narratives, games, social media, but especially for the purposes of creative expression, cultural analysis, and social empowerment. And I want to start off just with a little bit about my career motivation and underlying research motivation. So two underlying observations on media and computation motivate me. The first is a reflection on the media works that influenced me the most intellectually and impacted me the most emotionally, while also transforming society by engendering critical awareness. Now, these works build imaginative worlds that we engage with while reinforcing or challenging our concepts, worldviews, and values. The second observation regards the ways that computers influence everyday life. So of course they're pervasive now, but I think they're underdeveloped in the capacity to engender the kind of imagination of the media that I just described. So my research is a desire to close this gap and to go even further by developing models to better understand, principles to develop the computer's potential as a cultural medium in its own right. So this is the structure for today's talk. So after a brief introduction, then there are two parts of the talk. So one, I'll talk a bit about my book, Phantasmal Media, here that Margaret mentioned, and a kind of more comprehensive and broader view about subjectivity and computation. And then the second half will be focused on a particular type of subjectivity, which is that of our cultural identities as they're built into computing systems like avatars, computer games, social media, and so forth. And then finally, I'll conclude. So to begin with, the book Phantasmal Media is a book which attempts to develop a language to describe how subjective and cultural values are built into computing systems. It also offers methods for analyzing subjective content and cultural values implemented into computing systems, and principles for design of such systems, especially when used to empower users. So one of the motivations here is that computers are often be objective acultural machines, useful for things such as productivity or e-commerce and so forth. But my contention here is that all technical systems are in fact cultural systems. And furthermore, computers can be used to implement many forms of subjectivity. So where do I get this concept of phantasms or phantasmal media? So I'd like just to give you a bit of intuition for this idea in the introduction, or as I prefer to put it, the story of Bron as he goes to the bazaar. Yeah, so this is Bron, right? So Bron loves to buy, he loves to shop, he loves to go to the bazaar. And Bron has a particular and peculiar set of preferences when he buys. So he likes to buy from people that look something like him. He likes to buy from people that adorn themselves in the manner of his clan. He likes to see other buyers walking away from sellers with smiles and so forth. He also is a bit prejudicial, or quite prejudicial, because he prefers to buy from men and so forth. And so my question is, what happens when Bron encounters a seller that looks like this? Right. So what I'll begin to do is explore the reason for Bron's consternation here. And so this, of course, is the eBay seller's profile. And so let's look just at one portion of the seller's profile to analyze. And so this, I've just highlighted the seller's name. There's a bit of punctuation, as well as a star rating and a seller rating. So the numerical value here means that 1 point has been given for every positive rating by a buyer, -1 for each negative rating, and no points for neutral ratings. The green star just means it's in a threshold of 5,000 to 9,999. And there are a number of ways that this could have been implemented on the back end. For example, we could imagine that we have a string for a name, the feedback score is an integer, and we have a GIF file for the star and so forth. Yeah, so this is uncontroversial. Of course, we could have also represented it another way on the back end, say as matrices of pixels, which it is represented at some level. Now, each of these representations allows different kind of operations to be performed on them. Right? So, for example, it's much easier to compare the numerical value of a feedback score using an integer than a matrix of pixels. Of course, with a matrix of pixels, we can compare the contrast or color and so forth. Now, each of these are different representations, but eBay could have just as easily implemented it using something like this, which is Bron's way to represent a seller, right? So a Boolean value representing maleness, hygiene ratings, and so forth, reflecting the kind of seller that Bron likes to buy from. And the point of all of this is just to say that each of these represents a seller backend in a way that encodes aspects of worldview within a data structure. So that's to say that the eBay example is no less value-laden than the Bron example. Right? Those values are just selected for the purposes that eBay's user analysis metric has revealed. And so what I'd like to say then is that both of these implement phantasms. So when you have an image such as an interface that's uncontroversially and immediately accepted without conscious processing of the values underlying it, then that's what I'm calling a phantasm. And that's what I'm beginning to get at with the idea of phantasmal media. Here's a definition. I'll unpack it through examples. But the idea then is that phantasms are blends of mentary or sensory imagery with concepts drawn from particular worldviews that can be described in a formal mathematical way that's useful for analyzing computing systems. Right? And so I'll go on and describe this in a bit more detail through the use of examples. And the reason I use this concept rather than more familiar terms such as sign system or culture and so forth is just because I feel that this notion of phantasm really emphasizes the role of worldview and the semi-visibility of concepts within culture. In the book, it's pinned down in cognitive science terms and emphasizes the role of embodied and distributed cognition in processing, so the way that we offload part of our processing on the image itself in order to immediately make sense of it without consciously trying to interpret it. And then finally, important for analyzing computing systems is that we can begin to formally or semi-formally use the phantasms in order to aid in analyzing or designing computing systems. And so I want to give you just a bit of the theoretical framework, so the disciplinary background that I'm drawing upon, before giving an example of analysis along these lines. So from computer science, which is my PhD discipline, I draw upon the work in algebraic semantics. So algebraic semantics is a field in which we try to understand the meaning of the functionality of computer programs. So it's a quite mathematical approach to procedural meaning. Expressive artificial intelligence. So these are people in artificial intelligence exploring topics such as interactive drama, believable virtual characters. A lot of this work was started by Joseph Bates at Carnegie Mellon University, but forwarded by people such as Michael Matthias and Phoebe Singers. In cognitive science, I rely upon work in cognitive semantics. So this is work looking at how people construct metaphors, map one concept onto another concept, how people generate concepts from other concepts, analogy, and so forth. And in media theory and information science, I draw upon ideas from software studies. So these are digital humanities practitioners who look at actual code and begin to look at the meaning of underlying the code and its cultural impact. And then critical technical practices. So this is people coming from artificial intelligence, but critical of some of the philosophical underpinnings of the field. And so Phil Agree's term, critical technical practice, suggests that engineers should critically evaluate the underlying assumptions of their practice as a means of progressing their engineering work. And so the following example would demonstrate the roles that this theoretical framework plays in the analysis and design of phantasmal media systems. So phantasms provide a lens, again, through which to view how subjective experience and worldview are implemented within structured digital media systems. So for this example, I thought, what could be more challenging in some way to ask than, could a computing system represent something as subjective as poetic meditation on life and death? And if so, how could such a system function? So poetic meditation on life and death is nothing new to the arts or nothing new to media production. Right? In painting, we have memento moris that remind people of their mortality. We have poems such as Emily Dickinson, Because I Could Not Stop for Death, which personifies the figure of death. And we can begin to say, what are some commonalities or what are some of the ways that these kind of works have functioned? Building on the work of Lakoff and Turner, we can say that there are some basic metaphors that underlie a number of kind of poetic works. And so the basic metaphor, life is a journey, is one that maps the familiar experience of a journey, something that we've all encountered, onto the more abstract notion of life, and allows us to make inferences about life from this schema of a journey. So the person leading life is a traveler, his or her purposes are destinations, the means for achieving purposes are routes, and so forth. And we can make inferences, Lakoff and Turner argue, such as, what if we encounter an obstacle in life? What does it mean to overcome it, and so forth. And so what I'll talk about now is a computer game that begins to represent some of these kind of issues that Emily Dickinson has portrayed in her poem. So this is an art game called Passage by Jason Moore. It was for a competition called Gamma 256, in which the entire screen had to be less than 256 by 256 pixels. Right, so you have Jason here. He wrote this game after a good friend of his died, and he's meditating on these kind of issues. You can choose to partner or not partner within the game. You're translated constantly from left to right as you move throughout the screen. As you move across the screen, you accumulate points. Those points are in fact meaningless, but can be bolstered by finding treasure chests within the environment. If you have a partner within the game, then those treasure chests are worth more, and you accumulate more of these meaningless points, but it's harder to navigate the spaces within the game, and so forth. As you go further through playing the game, the character has begun to change, translated further towards the right side of the screen. Before, we had a blurred area on the right side that represented the future, which was compressed. Now the left side is becoming more obscure, so you're beginning to remember less of this. It begins to slow as you proceed. The spouse passes away, and the character finally begins to approach the periphery of the experience, and the character himself is then replaced by this garish tombstone. And that's the way the game always ends. Right, so it's a 5-minute game experience, and this is the way that the experience always goes. Now this is an independent game that was an award-winning game, critically acclaimed game, and a number of people, myself included, found it to be extremely poignant for a 5-minute experience. And so one of the things I began to ask myself is, why does this game achieve this kind of poignancy? Can we look at that in terms of design principles? Can we analyze the game to better understand its function and how it implemented the subjective ideas within its functionality? And so what I did was begin by doing a cognitive linguistics analysis of the artist statement about the game. And so this is, on the right-hand side, we have quotations by the artist. And so on the left-hand side, we have the conventional metaphors that they're evoking. And so, for example, there are notions such as directionality, moving toward the end of life, the future is to the left, and so forth. Lifetime is a space, is represented by notions such as the territory in front of you, and so on. And so you can see that through his language in describing the game, he's really evoking some of these kind of basic metaphors, such as life as a journey and onward. And so I identified a number of these kind of metaphors. Memory is visibility, the future, the past becomes obscure, and so forth. And so after realizing that there are these conventional metaphors implemented in the game, I asked, but how would a game developer begin planning a system based on this? And so here's where the algebraic semantics comes in. I don't expect you to read all of this just now, but one of the things that Joseph Goguen did was begin to apply this algebraic semantics for mathematically looking at the functionality of computer programs to interfaces and understanding the values that are built into interfaces. And so one of the things I did with the book was to translate that mathematical formulation of algebraic semantics into what I think is a sort of more cross-disciplinarily palatable formulation of some of these ideas. And so, it's a kind of semiotics. It's a structural approach to looking at how meaning is conveyed, in which we begin looking at the types of things that are there. So you could imagine that you have a window, we have a sprite, which is the animated figure, you have numerical representations, we have constructors, which build signs out of other signs. So for example, pixels can be used to build the sprites. You have different images that are then used to build animated images. We have subsort relationships between different items. So you might have a particular, the player character is a subsort of the type of animated character. We have levels that indicate part-whole relationships. So we have the entire screen is a part of the window and so forth. And some functions and axioms that constrain the possibilities for the functionality of the system. Most importantly, we have a partial ordering on the relative importance of the different items within the game, the different items on the screen. And so the sort of process that a designer might undergo is one in which you take these underlying metaphors and then begin to think about how those are going to be realized within an implementation. And so you have here constructors for the space and the maze that you're traveling through. The past, present, and future are these three subdivisions of the screen, the obscured area on the left, the middle where you're navigating, and the right, and so forth. So it's just a structural description of the different elements of the game that we saw. And so it's the sort of thing a designer might come up with as she or he is developing specs for the system. And the problem of design is taking those specs and then realizing them in a particular implementation. So it's a problem of mapping. You're trying to map the specifications for the game onto the realization of those in the actual computer program. And so one of the ideas here of what I'm calling morphic semiotics is that you can begin to look at trace the subjective values encoded in these metaphors through a kind of planning document and then finally through the implementation. And you can judge the effectiveness of the implementation in part by looking at the way it encodes the priorities, and so the values of the different elements within the original space. So for example, a higher priority element might be the player character, say, than the spouse who is optional within the game. And so what we find in the case of Passage is that the priorities are largely preserved from the metaphor to the final implementation. So for example, the most important element is the entire screen, which represents the life. Of next greatest importance are the player character and the tombstone that replaces that character. The player character and the tombstone are important because reflection upon oneself and one's eventual death are aspects of the poetic meditation that are central. We have next the concepts of past, present, and future that are of subsequent importance, and so on. Right? And so we have the spouse, and walls, chests, and treasure being less important than her. And so the idea is that it's just a structural way to then think about the way that the values from the metaphor that are being meditated on are implemented finally within the system. And so just a check to say that so far what we've done is just begin to look at how Phantasmal Media looks at technical aspects of computing systems in order to see how they represent subjective content, such as the underlying metaphor of the game we just saw. And so what I want to do with the remainder of the talk is look at technical aspects of a particular type of subjective and cultural content, which is social identity. So this is going to be described through the lens of a 5-year project, an NSF-supported endeavor called the Advanced Identity Representation Project. And so first, just to give you a sense of what I'm talking about when I speak about computational identity, we have a range of ways our identities are now implemented in computing systems, say as game characters, as profiles, online accounts. Many of these interoperate with one another. So for example, you might have to log in to Facebook in order to leave comments upon a particular article. And the question, and these systems all require us to take our social identities and mitigate them through computational data structures and algorithms. And these algorithms often have less social nuance in the way we express ourselves in the everyday physical and social world. And so a question for me then is how can we represent ourselves computationally in dynamic ways sensitive to issues such as power relationships and other kind of social issues that we have to navigate in the real world. And before going on, just a reminder is that not all phantasms, so we're going to look at phantasms of identity, but not all of them have to do with identity. And then also the notion of identity here is not limited to race, gender, and canonical aspects of identity, but also fashion, body language, facial expression, personality, and some of this kind of other kind of subtle and expansive aspects of identity. And to motivate us, I want to talk about a bit about some of the kind of challenges with current systems. And so these are screenshots from a video game and from ancillary material about the game. This is Redguard, which are the ostensibly African characters in this game called Elder Scrolls IV: Oblivion, a major game, bestseller on a number of consoles. And if you begin to read the material about the game, and even on the screen here, you see that the Redguard are described in very essentialist terms. So they're described in the essentialist stereotype of the black athlete. They're the most naturally talented warriors. They're blessed physically with hardy constitutions and quickness of foot. So in fact, in game terms, this translates to bonuses of their running and jumping abilities as they play. And similarly for Nords, the ostensibly Norwegian characters within the game, they're also prioritized for their physical abilities within the game. And so you could ask with the sequel game to this, Skyrim, which say the first week of sales generated US $450 million, so it's a major game. They did change the representation of some of these characters just a little bit. I'd been writing a bit of critical work about this. We can ask, was it improved? What was the effect of changing it? Well, the sequel game, so the character looks something like this. So I leave it to you to say whether it's improved or not, but I would contend that it's not, because what's more interesting to me is the fact that underneath the surface, the underlying statistics, let's say, if we just look at even the intelligence, if you happen to play as a Nord or Redguard, you're going to be by default 20 points less intelligent than your Breton counterpart, the ostensibly French group within the game. Right? If you happen to be a female orc within the game, you're by default 10 points more intelligent than your male counterpart. Right? So the idea is that these differences of value are not just graphical differences, such as a critique of body image of a character, a worthy critique, but these are implemented within the system itself on the back end, something like the values in the eBay example. But we can go a bit further than just stats, just numerical default stats. And so this is an example from an earlier but also best-selling game called Neverwinter Nights. And in this game, there are data structures that are actually implemented. And this is not my gloss. These are actual names of the data structures for race, phenotype, gender, and so on. And so I could ask you about your disciplinary definition. So within your discipline, how do you define phenotype? Okay, well, so there could be a range of different definitions, I think, is what this response means. And what I would guess is that as you think about it, probably your definition doesn't just mean whether the creature's of normal or large shape, right? So I could ask you, does race have anything to do with appearance? Right? So you might give me a number of different answers, again, depending on your discipline. But in this game, you might not have guessed that race, in fact, changing race will not change the appearance of your character, yet many items have racially based bonuses. How many genders are there? So another question, I could get a range of answers, but within this data structure, you have 5 genders in this order: male, female, both, other, and none. However, if you happen to play as male, both, other, or none, and you're one of the standard races, you have a default male body type. Right? So we have 5 different genders represented, 80% which of them are visibly male within the game. Right, so There are a number so I'm not going to go over all of these, but there are a number of limitations of the current ways identity is represented in computational systems. And so simplistic models of community membership, such as in social media, joining a group is just opting in, click a button, opt out, click a button, much different than in the real world. Social categories reduced down to just stats. What about representing transitioning identities, such as the state of becoming an expert from being a novice, right? So these sort of things are difficult to represent within a lot of these profiling systems. You might also ask, why is this important? Well, it's important because we map ourselves into these identities and they change real-world behavior. So some of my own research, as well as research of Jeremy Bailenson here at Stanford and in the audience, shows that changes to virtual representations directly impacts issues, in Jeremy's case, looking at interpersonal confidence or body image, and in some of our work, looking at students' perceptions of themselves as learners and doers within computational learning. And so addressing these problems allows us to better serve diverse user groups, provide greater customizability, and more expressiveness of these systems in general. So in short, we have to do better than these current systems. And so that's what I've been working on. So the Advanced Identity Representation Project is named not because our systems are so advanced, but because the current state of identity representation, in some sense, is often quite simplistic, right? Just some number of attributes defines whether you're a member of a particular social category. And so what we've been doing is developing new models and new theories in order to look at some of these issues. New platforms, so these are systems to help implement social media or games that have engines to model more nuanced dynamics of identity, and then new applications, that's particular kind of games or social networks using our platform. And very briefly, just a bit of a theoretical framework building on what I've already mentioned. So some of the things that we've been doing is, so identity is very broad. One way we narrow it to focus in the engineering sense is to say, let's look at how how categories are implemented, because people are always categorized within computational systems. There's work coming out of cognitive science that looks at, say, prototypes. You might have a prototypical member of a category. So Eleanor Roche famously described robins as a prototypical bird, right? And whereas, say, an emu or a penguin are sort of more further removed from a central member. So this idea of centrality gradients developed by George Lakoff, in which you have, again, gradations of membership within categories. We've also built upon work of Jeff Bowker and Lee Starr, so thinking about how people become members of categories, how people naturalize and change over time, being marginalized from categories by being members in multiple categories or on the boundary of categories. And then also I've looked at shared technical underpinnings. So that's work where at some computational level, you can construct a graph that represents a Facebook profile or a computer game character. You have flat text profiles here, network links between affiliations, and so forth. And in fact, a lot of the same kind of metrics will work on both. So it's not a case where you have to be restricted to one particular medium, virtual worlds or social networks. And so I'm just going to talk about one project we did for the sake of time today, which is called the Chimera Platform. And so I wanted to tell you a bit about what Chimera does and what the platform offers. Well, it offers support for the kind of category gradients, modeling prototypes, and category dynamics that I just spoke about. So to make that a bit more clear, so imagine if you're playing a computer game and you're playing as a knight, right? You love to fight with sword and shield. But then you begin dabbling just a bit in magic, and so you might still have your sword, but practice magic a little bit and decide that, in fact, this magic stuff is not quite to your taste, and then go back to being a knight. However, then the idea of sword and shield have lost their luster, and you decide to go, as I say, full mage. So you can imagine a story in which you're listening to Pandora or your favorite music recommendation system. You begin listening to punk rock music, primarily from the UK. You begin dabbling just a little bit in bebop jazz. You go back to listening to punk rock music, and then go full jazz. Right? So you can see that the structure of these stories are parallel. And so what our system does is provide an engine that mathematically models these kind of shifts of identity category over time. We also have a graphical user interface for editing stories and building platforms within this. We are tied into a number of different knowledge bases. You can tap into systems such as YouTube, Rovicore, Facebook, and other systems, or program your own knowledge bases for this. And then finally, we built some systems atop of this. And so this is just a screenshot to say for the interface for building a computer game using the system, just so to suggest you can build narrative elements, bring in animated assets, and so forth. And so to describe one application we built using Chimera, I'll bring you through this example using the case of just two social categories that we're modeling. And for the sake of example, we'll call these categories the Sylvans and the Brushwood. Right, so the Sylvan are, in this example, going to be lovers of fine clothing, poetry. They tend to be tall on average. Whereas the Brushwoods are small people on average. They love earthy homespun clothing and good hearth tales. Now, we're not restricted to this kind of fantastic setting within the story. So you could reskin this on the surface, and so Sylvans and Brushwood could look like whatever you want in order to represent them within the narrative. So here's another. And so what that's described is that we've separated out the abstract configuration between different social categories. So for a very simple example, we could think about, as Irving Goffman puts it, the normal or accepted kind of category from the point of view of a society, and the stigmatized or discredited category. We could have any number of these in different configurations. And then separate from the abstract configurations, we also have concrete categories. And these are based in particular worldviews. So we have a prototypical Brushwood, is what I just described. That's not all Brushwood. Or a prototypical Sylvan. And so we have features represented such as clan, gender, and some continuous features, height, speaking ability, and so forth. And so you could have then a prototypical Sylvan in our system, right? It's tagged as Sylvan, but we have a continuous variable for height, clothing, and speaking. We have similarly prototypical Brushwood. So again, we have different variables for each of these. And we've implemented category gradients in the sense that you can be a more or less prototypical member of the clan. So for example, you could be a well-dressed, elegant Brushwood, which from the point of view of a Sylvan, if it's say within a particular Sylvan worldview, could be seen as passing as a Sylvan. So it's the idea that you have a character that is identified by self from one category, and from another's point of view, they seem to be exhibiting the characteristics of this other category. The other thing that we've implemented with Chimera is this idea of naturalization trajectory. So we track these kind of changes of category over time. So that means that you could begin as the Brushwood I mentioned, but say the clothing and speaking ability begin to change and increase if you're looking at it from a Sylvan point of view. And there might be some threshold in the Sylvan worldview after which the character is then accepted as a Sylvan. And so this acceptance threshold can be what we call a threshold for a passing. And so what we did using these kind of category gradients tests and tests for the naturalization trajectory is begin implementing different kind of social functions for how we manage our identities in the real world. And so even going back to early sociology, I should say seminal sociological work of Irving Goffman on stigma, we have these phenomena such as passing, such as a literate person putting on glasses in order to seem more illiterate. We have slipping, where say one's true accent kind of shows through the facade, and a number of these kind of behaviors. What we've done is take our naturalization trajectories and then map those onto strategies and outcomes within the system. So I describe, so intentional passing would be monotonically increasing your membership within the group, say within the Sylvan group. We might have something where you have inadvertent passing, where you've mostly been able to pass as a member of the Sylvan, but at sometimes then you've lapsed from that point of view. We might have slipping, in which you end up failing to express yourself as a member of that group, and so on. So the idea is now we have a kind of algorithmic way to begin to capture some of these kind of phenomena that in current games are just hard-coded. There's no model underneath it. Usually it's just a text change. If you are an elf, then text replacement, welcome elf, instead of welcome human. So most systems don't have this kind of nuance underneath them. And so what I'll do is just show a demo of a game that we made using the platform. So this is Chimera Gatekeeper. And so the Sylvan and Brushwood have been at war for ages. The Sylvan, known as tall people on average, as you know, are lovers of finery and elaborate poetry. The Brushwoods, known as small people on average, are sometimes judged from afar to be fond of earthy homespun fabrics and good hearth tales. Hailing from the Sylvan tribe, so remember you are Sylvan in this example, because I'll ask you for your input. You stand before the gate of a keep. You need to enter, and the need is dire. You are tall, wearing fine clothes, and articulate. You see a brushwood guard with sturdy armor. The guard looks preoccupied, and he does look a bit preoccupied. So what do you do? So do you dust off your boots, adjust your clothes in your gilded mirror, untuck your tunic, or hide your fine jewelry? So what do you do? Okay, so we'll hide our fine jewelry. He smiles approvingly. He likes that. Right, and you think to yourself, I'm trying to fit in with these brushwoods. He stands before you, ready to size you up. Do you do nothing, straighten up, or slouch? Okay, I heard some straighten up. Oh, he doesn't like this. And you think to yourself, it doesn't seem like he wants me in. The guard looks curious, and he looks expectantly at you. Do you say, May Govenen, which is a Sylvan greeting, say, greetings, small one? Or do you say, hello, greetings, brother, or good day, Brushwood? Okay, so greetings, brother. He likes that. And you think, I'm trying to fit in with these Brushwood. He has a wary expression, and he asks you, we don't see many new folk around here. Did you travel far to get here? It seems he's going to say we don't see many Sylvan around here. And so do you say, 'tis not far from home? Oh, yes, good man, this is a strange land to me. New, I'm from just around the way, or I'm from a little ways off indeed. Okay, so I see some nods. He doesn't like this. And it doesn't seem like he wants you in, you think. And I guess he says you can come in. And so at the end, that you think to yourself, the guard let me in somehow, but Sylvan seem unwelcome here. And so I want to show you, and this time I won't ask you for the answers, but just going through very, very quickly. And so again, so here I'll say, I'll adjust my clothes in my gilded mirror, speak in my own language. And I think to myself, I'm being true to myself still. And you say, I'm from a ways off. He's before me. I'm going to straighten up tall. And I'm not welcome here. But at the same time, I think, well, I'm a Sylvan, and I won't change myself or pretend to be something I'm not. I'll find a way inside or go somewhere better. And so we have these two different valences of outcome. We have whether you actually got in or not, but also your internal self-conception. It can change depending on the outcome. And so we also have as a narrative model underneath it, so that we can implement a variety of kind of narrative. This is based on social linguistics narrative of personal experience and so forth. And you can toggle on some of the values. There are two types of tests being given as you go throughout this experience. So these are a number of outcomes represented here for whether you get in or not. So these at the bottom are where you don't get in, and these are where you do. And each one represents a different kind of theme. So for example, we could have just acted as a Sylvan the entire time, but there is a theme which is called stigma, allure, or exoticism, in which at the end they would have said, welcome, come in, we need a little Sylvan flavor around here. Right? And so you have different themes such as acceptance. We have the right tests, and so you could have gotten, thankfully I was able to get in. We could also have had the theme of denial of self, and although you do get in, well, I had to pretend to be something I'm not in order to get in, and so forth. And so I wanted to just end with just one more demo, because the system isn't just used for making computer games, but also we can think about identity in social media. And so what we've done is represent a kind of social network site that narrates the kind of conversations that people might have about music. Music also being a kind of indicator of identity. So Hargreaves and others have discussed music as a kind of representative of identity, national identity, gender identity, and so forth. And so let me just run this system. So you can log in either through your Facebook account and use your ostensibly real musical preferences, or you can enter them into the system. And so we are CASBS. And so in order to categorize your musical taste, we need a few different artists. So can you give me 3 different musical artists? Okay, so John Coltrane, Charlie Parker, and Philip Glass, that'll be it. So Charlie. Right. Yeah, so we're tapped into the Roe v. Core cloud services. That's what powers the All Music Guide here. And Philip, is it 2? Here we go. All right, and so what the system then begins to do is compute what kind of musical taste you have. I mean, we don't give it that much information in this example with 3, but what kind of category you fall in, according to a distance metric in the AllMusic Guide, what's a kind of oppositional category, and then based on a model of conversational narrative, so how people put topics on the table, take topics off, and so forth, we simulate the kind of conversational story or conversational narrative people would have about this type of music. And the photo wall represents your music taste also. So Carson says, good to see you. That's just an intro. But somebody who likes deep funk revival music begins to say, do you know who's great? Jari Blue Afrobeat Orchestra to you. And so we have our thread of comments on the left, like a timeline in Facebook. And also this text, Jaru Blue Afrobeat Orchestra is wonderfully earthy, is not pre-written. So this is drawing upon themes and moods that are associated with that category in the system. And so this is so wonderfully earthy. You can drop, so we're bringing in a clip from YouTube. You can say, do you like it or dislike it? Okay, I see some ambivalence, so we're going to dislike it. Right, but Tony Parker comes in and says to you, and this is just for your convenience, we've labeled him, I always knew that deep funk revival music was too gutsy for you. And so we have somebody else that comes in who likes chamber music, which I guess Philip Glass suggested, and you know what, Bach always makes my day better. And his music is so wonderfully ironic as it is. Right, and so we can listen to a bit of Bach and decide if we like this. So this is just the intro, but let's say that we like Bach. Right, and so someone says, I never understood people then who like chamber music. And I'm surprised, this funk member says, that you're actually still listening to chamber music. Right, and so they suggest another kind of video here, and I won't play it just now. Right, and somebody else who likes chamber music says that in fact is too brassy for my tastes. And so what we're doing is tracing the membership of categories, but this time through a kind of conversational narrative. And so let's say that we like this one. What? I never pegged you for a deep funk revival in that. And so forth. Right, so this is great smooth music. Let's say that we like this one. You know what, it's embarrassing how much you like chamber music. I'm surprised you're still listening to that music, the funk person says. You don't belong in the funk group, just keep listening to your chamber music in the end. Right, and so what we've done is, within a different kind of system, we've represented this kind of membership. So we could represent it just as a graph rather than as a narrative, for example. We could also represent it as we do here. We're not limited to kind of virtual novel style game like the one that I showed you before. We could represent this as an interactive 3D game. Right, and so in this case, so this is just built in Unity, where we have your membership in each category, just as a demo, is changing the color of the shirt. So if you're more one category or another category, it'll be more blue or green. But that could change any kind of factor with a 3D representation. So again, just different ways to realize this transition of identity over time. And so in a way, so Chimera then offers researchers and developers support for representing category gradients and category dynamics. And it also enables systems to help in revealing phantasms of identity through modeling aspects of phenomena like stigma, marginalization, intersection between multiple categories, and so on. So remember good old Bron from the beginning of the talk. Well, the reason I'm reminding you of Bron is just that phantasms, such as we see here, often remain implicit and invisible to users. And so what I've done at the Chimera system is develop kind of these phantasms of identity that are theoretically grounded, explicitly designed for social modeling and for expression. I don't have time to go into all of our projects, but you can look at our website. We have a number of different projects, systems dealing with issues of microaggression from clinical psychology, a system addressing the Truth and Reconciliation Commission of Liberia. We do some analytical work predicting how status is performed in a virtual world from Facebook profiles and so on. So you can take a look there. Also gestural work, a game in which you can navigate by eye rolling and attitude and so forth rather than traditional input. And so I just want to conclude now by saying that what I argued in the book is that we can approach computing in a way that is subjective, cultural, and critical, all topics that are usually associated with computing, of course, right? And my contention that great expressive, critical, and empowering uses of digital media will result from effectively using their unique computational means of prompting and revealing phantasms. So, thank you.